1. Task introduction. In modern industrial automation, precise control of servo motor motion is crucial. For example, 1 to 4 axis devices such as 4-coordinate robots often use pulse control mode to achieve accurate positioning and speed regulation. This lesson will explain how a PLC controls a servo drive via pulse commands, as well as the logic behind key parameter settings, such as electronic gear ratio and pulse type. 2. Learning objectives. 1. Understand the applicable scenarios and working principle of pulse control mode. 2. Master the calculation and configuration of the electronic gear ratio. 3. Distinguish the characteristics and suitable conditions of the 3 types of high-speed pulse outputs. 4. Identify the core differences between PTO and PWM outputs. 3. Guiding questions. 1. Why is pulse control suitable for devices with fewer axes, such as 4-coordinate robots? 2. How does a servo drive achieve precise position and speed control in pulse control mode? 3. What are the setting rules for the electronic gear ratio parameters, EA03 and EA04? What format should the values follow? 4. When transmitting pulse signals over long distances, which pulse output method offers better interference resistance? 4. Knowledge description. 1. Pulse control principle. Application. Primarily used in 1 to 4 axis control systems, e.g. single-joint robot control. Multi-axis systems should switch to bus control. Control logic. The PLC sends commands to the servo drive via high-speed pulse output ports, while the drive operates in position mode. The drive employs a 3-level closed-loop control system: position loop for positioning, speed loop for speed regulation, and current loop for torque control. The number of pulses determines the motor's movement distance, and the pulse frequency determines the motor's speed. 2. Electronic gear ratio setting rules. Calculation formula. Electronic gear ratio equals EA03 numerator divided by EA04 denominator. Parameter configuration. When EA02 is set to 0 to 2, the electronic gear ratio must be set manually. Default values. EA03 numerator equals 1000, EA04 denominator equals 1000. Display rules. Decimal display. If the value exceeds 10,000, it automatically switches to hexadecimal. 3. Pulse types and output methods. The pulse control types for servo motors mainly include 3 modes: pulse plus direction, pulse plus DIR. The pulse signal controls stepping, and the DIR signal controls rotation direction. Uses single-ended signal transmission with weaker interference resistance, requiring 2 signal lines. Mainly used with PNP-type PLCs, e.g. S7-1200. Dual pulse, CW plus CCW. Separate CW, forward pulse, and CCW, reverse pulse, signals control movement direction independently. Uses differential signal output with strong anti-interference capability, suitable for high-speed applications. Typical for modular PLCs, e.g. Mitsubishi QD75. AB phase pulse. Uses a 90 degrees phase difference between A and B phases to determine rotation direction. A leads B equals forward. Provides high positioning accuracy. Requires 2 signal lines, commonly used in encoder signal transmission. Common characteristics. All 3 control types require 2 signal lines to implement motion control, but differ significantly in signal definition, interference resistance, and application scenarios. Pulse plus direction is low cost, but has weak interference resistance. Dual pulse offers strong interference resistance, making it suitable for high-speed, long-distance transmission. AB phase pulse provides both high-precision position and direction feedback. 4. PLC pulse output comparison. PTO, pulse train output. Fixed 50% duty cycle, adjustable frequency. Specifically used for servo pulse control, e.g. position and speed mode. PWM, pulse width modulation, adjustable period and duty cycle, suitable for speed control, temperature control, and other non-servo applications. The core of pulse control mode lies in driving the servo motor via the number and frequency of PLC output pulses, converting commands using the electronic gear ratio parameters, and selecting the pulse type based on transmission distance and interference resistance requirements. Dual pulse recommended for long distances, AB phase for high precision. Parameter settings must strictly follow the EA02, EA04 configuration rules.